So, as I was saying, you're going to, this is why I said, some of you might get this right away. If you do, great, but you need to keep in mind that some of you might need a little bit more time for it to kind of sink in. And it's something, if you don't understand it, if it doesn't make sense, you have to come see me right away. So like tomorrow bonus, if it's not making sense, come in to see me, because it's also going to show up the rest of the book, like what we're covering. So when we do area and volume, which will be coming up in later chapters, depends on your knowledge of these special right triangles.
Should I run quickly downstairs to get my packet? I brought the wrong binder.
Okay, so there are two types of special right triangles. The first one, and the way we determine whether they're special right triangles are going to be based on their angle measures. So the first one is a 45, 45, 90. So whenever you hear the words 45, 45, 90, you should start to picture what type of triangle we have. Now I want to talk about, where does a 45, 45, 90 triangle come from? It comes from a square. And if you take the diagonal of a square, okay, so take a square and you're going to cut in half diagonally. Okay, so if you cut it in half diagonally, what do we know about the diagonals of, well, a square is a special type of rhombus. So when you have the diagonal, this bisects the angles. So if these start out as a 90-degree angle, then this has to be 45, this has to be 45. What?
She's a diagonally wow.
Got it. Now I see. Okay. Okay, so taking the idea of a square, right? Let's just take an example where the sides are both 1. If you were to do, what did we learn in the last class? Pythagorean theorem. Okay, so using a squared plus b squared equals c squared, go ahead and find the hypotenuse. Find c. Shouldn't take too long. Don't use your calculators. I don't want a decimal approximation. So you'll have 1 squared plus 1 squared equals c squared. Okay, 1. I'm just using the ones as an example. Oh, I just said it's going to be in all high school math. So basically I'm just saying that, you know how sometimes you have a concept, you're like, oh, when are we ever going to see this again? Like geometry proofs? Geometry proofs, if they don't make sense, don't worry about them anymore. Okay, because you're not going to have them in algebra 2, you're not going to have them in pre-calculus and so on, but special right triangles you will. Question?
Will you have them stat?
No, I meant the calculus. You guys, being in the honors track, and I've talked about, I'm not going to take it, like, you're on track to take AP calculus. Taking stats is not you can do that, but I'm just saying, you are on the path to be an AP calculus. Statistics. You can come talk to me on your own time if you'd like to know more. Okay, now, let me just give you, do another quick example. Imagine you had a 45. Guys, please stop. Let's say, just take a different example. So here it was 1, 1, your hypotenuse ended up being square root of 2. Just try another example where it's not 1. Okay, so it needs to be 45 degrees because, okay, what did we do in chapter 7? Chapter 7 was on similar polygons and similar triangles. So what we're actually trying to look at is every 45, 45, 90 triangle will be similar to another 45, 45, 90 triangle. And what I'm basically showing you is that there's a relationship between the legs of the isosceles right triangle and the hypotenuse. So when we do this one, we have 3 squared. Good, so we get 9 plus 9 is 18. So when we take the square root, it ends up being 3 root 2.
So is it always root 2 and then whatever the other sides are?
Okay. So whenever the sides, and when I say the sides, I mean the legs specifically. So whenever the legs are like a whole number. So here we had 3, 3. This one ends up being 3 root 2. What if this was 5, 5, and 5 root 2?
Is that always the time?
Exactly. So
it's always going to be root 2.
okay, I don't want to say it's always going to be root 2. Because what if all of a sudden I gave you the leg was square root of 6? Square root of 6, square root of 6,
Square root of 12.
square root of 12.
Oh my god, I'm so
Wait,
smart.
what?
Guys.
Okay, so the hypotenuse
Why is it square root of 12?
is square root of 2 times the leg. So when I said square root of 6, square root of 6, square root of 6, if I take that and I multiply by square root of 2, I get square root of 12, which would be 3 root 2. So it all depends on what you're given. What you need to remember is the length of the hypotenuse is always going to be square root of 2 times the leg. So if this is n, this is n, this is n root 2, no matter what. Now what if you have the hypotenuse and you have to figure out the length of the leg? Well, what's the opposite of multiplying by? Divide. So if you want to figure out the leg, oops,
Divide by 2?
no, divide by square root of 2. Yes. I think I need a new battery. So you're going to take the hypotenuse and divide by square root of 2. Yeah, when you multiply a number times square root of 2, you just put the coefficient in front of square root of 2. Okay. It's okay, we'll fix it. Okay, why is it square root of 2? When we do Pythagorean theorem, notice the 2 legs, A and B, are always going to be the same. So imagine that you don't have A and B. It's A and A, right? Okay, so think about it in terms of this. What do we know? We know that A squared plus A squared is equal to C squared. Okay, now, Henry, I'm going to move you. Okay, so 2A, we have 2 of them, right? 2A squared is equal to C squared. So if I were to take the square root, what do you notice? What's the square root of A squared? Just A. But can you take the square root of 2? No. So C is always going to be A times the square root of 2. Yeah, you can write that down. That's basically the proof of a 45, 45, 90 triangle. So that's why you'll see that it does look like a long homework assignment, but what I'm trying to show you is that these are shortcuts. If you have a 45, 45, 90 degree triangle, and you know one side, it doesn't matter what that side is, it doesn't matter if it's the leg or the hypotenuse, you can figure out the other 2 sides by knowing this shortcut, that the hypotenuse is square root of 2 times the leg. Okay, take a look at this one. First of all, how do we know it's a 45, 45, 90? Okay, so these 2 sides are marked congruent. Just keep in mind, because we're going to do another special triangle, so you have to see the difference between the 2. So if it's isosceles, we know opposite angles are congruent, right? That's the isosceles triangle theorem. And if these 2 are congruent and this is 90, these have to be 45 and 45. There's no alternative. Now, x is really easy. There's no work for x. It's labeled congruent. So x is 5. And y would be 5 root 2. Exactly. Now, if you really wanna do Pythagorean theorem, check your answer, that's fine, but I'm just showing you that basically I'm showing you a shortcut. You're not innocent either.
What do people usually not understand?
What?
Like, you know, you said like you don't understand what you're saying. What
So
do people
it's a
usually not
relatively easy concept, but when I introduced the other special triangles and when I did, some students get confused.
The easy
Overall,
concept goes away.
I don't wanna make anybody feel bad, overall in the honors class, the students get it. And it's not a difficult,
I feel like it's bad that I do understand.
well, that's why I said I didn't wanna make anybody
Yeah,
feel
I'm
bad.
sorry, I'm not. It seems too good to be true. It's like really easy to say.
So how is that too bad? So, but, okay. Notice the hypotenuse is 20, and what I was just showing you is every time we were looking at the examples, it ended up having a root 2. Well, what did I tell you up here? If the hypotenuse, remember, the hypotenuse is equal to square root of 2 times the leg. So if the hypotenuse is 20, right?
Okay.
And the leg is x, you would divide by root 2. Now, if you just went right to dividing by root 2, that's fine, but you do have to rationalize. So when you rationalize, you're going to multiply. So you're going to take 20 over root 2, and you're going to divide, or sorry, multiply by square root of 2 over square root of 2. So you get 20 root 2 over 2, which simplifies to what? 10 root 2. I will tell you. So, 10 root 2. A quick way to do this, if this is a whole number, so like 20, if you just take 20 and divide by 2, you get 10, and then we'll have 10 root 2. How can you check your answer? Well, take this answer, multiply this by root 2, and you get 20.
And multiply it with that.
Yeah.
Wait, listen to
I was right. I said 10 root 2. Okay, so take, listen, if you have the leg, let me just summarize this. If you have the leg, you multiply by square root of 2. If you have the hypotenuse, you divide by square root of 2. That's it for 45, 47.
Square root 2 times square root 2.
2. And then 2 times 10 would be 20.
Well, wouldn't it be 2x?
No, I was just saying, if you know the leg is 10 root 2, that's what you solve for, to just check your answer, take this and multiply by square root of 2. Well, what happens when you have square root of 2 times? Again, to check, so let's say I wanted to do a quick check, take 10 root 2 times root 2, do we get 20? I'm just saying,
Oh, yeah.
take the leg times square root of 2, do we get back what we started with, which was 20?
So could you have just done 20 square root 2 equals 2x and then divided 20 by 2 and just 10 and then that would be 10 root 2 instead of doing all that.
Okay, so that's what I was just saying. Anytime you have, here, I could throw up a whole bunch of examples on the board, and you would, it's kind of like, it's just knowing the pattern. So if I give you this is 8, then what are these sides going to be? 4 root 2, 4 root 2. Right. What if I gave you that this was 7, then this side would be 7, and this would be 7 root 2.
Oh, so when you really just divide.
Right, what if this was 20, no, sorry. What if I labeled the hypotenuse as 28? Yay.
Just divide that one by 2.
And you added root sign. It's a quick way to rationalize. Okay, so 30, 60, 90 triangles. This is the other one. So how do we get a 30, 60, 90 triangle? We're going to take an equilateral triangle. Okay, we're going to cut in half by drawing the altitude. So the altitude starts here. starts from the vertex, goes perpendicular to the opposite side. An equilateral triangle is a case where the altitude is actually the same as the angle bisector and also the same as the median, which gives us some information here. Now, where is the 30, 60, 90? It's half. So we know this is 60 because it's equilateral and equiangular. So if this is 60, this has to be 30. Okay. Now, every 30, 60, 90 triangle is going to be similar to another 30, 60, 90 triangle. This is where the shortcut comes in. Now, if this side is 2, this side is 2, and this side is 2, when we draw the altitude, it's 1 and 1.
Is it always in half?
So
Because
the leg is half of the hypotenuse,
Okay, we'll get to that. We'll get to that.
and then that's
Okay.
times 3, root 3.
So this is 1, this is 1. Just look at this triangle though. Now that we have two sides, this is 1, this is 2. Could we figure out this other leg? Okay, so go ahead and do that. Like let's say this is A, this is B, and this is C. So go ahead and take a minute to solve. And just leave it in radical form. Again, this is why I said I don't want you to pick up your calculators and just put, I mean, you can do some of the mental math, but. So it's 1 squared plus B squared equals 2 squared. Okay, so I get 1, 2 to the hypotenuse, square root of 3. Now, 1 was opposite the 30-degree angle. We call this the shorter leg because it's shorter. And 60 is opposite the square root of 3. We call this the longer leg. Now, I want you to just, what? One's longer, one's shorter. Okay, how do we know for sure? Well, 60 degrees is bigger, and we learned that in first semester. The angle opposite the bigger angle, right? Or the side opposite the bigger angle would be bigger. Okay, imagine if we took another equilateral triangle. Let me just show you the pattern. Let's say instead of 2, I gave you 10. Okay. When I draw the altitude, this side ends up being 5. Okay, so the shorter leg is always half of the hypotenuse, right? Because remember, where does this shorter leg come from? It comes from an equilateral triangle that you cut in half. When you do the Pythagorean theorem, you're going to get 5 root 3.
so it's just going to be 3.
5 squared plus b squared equals 10 squared. So you'll get 100 minus 25 is 75. Square root of 75 would be 5 root 3. If I
In the
choose,
shortcut to that, it's just the leg. It's just the leg root 3.
no, it's not always going to be. Guys, I'm just trying to show you like how you know for sure. Like let's say I gave you this is 14, then this would be 7 root 3.
So you just multiply by root 3 instead of root 2.
Yes.
So now, what if I gave you what if I gave you this piece was 9? What would the hypotenuse be? Okay, you got it? So those were the,
This isn't that hard.
no, it's not that hard, it's just,
So far, this is my favorite guy.
okay, here's our theorem. The hypotenuse is always going to be 2 times the shorter leg, and the longer leg is square root of 3 times the shorter leg. That's pretty much the basics for solving a 30, 60, 90 triangle. The trick comes into, like, I gave you nice numbers that were easy to work with. You know that you're not always going to have those easy numbers, so that's where you have to remember. That's where you have to remember the relationship. Now, let's look at some examples. Okay, so I gave you which side? We have a shorter leg, a longer leg, and a hypotenuse. Okay, this is the shorter leg. So this is the shorter leg. This is the hypotenuse, and this is the longer leg. Now, I think for this one, it's pretty straightforward, right? We already said the hypotenuse is 2 times the shorter leg. So if the shorter leg is 10, then this is 20. Oh, sorry, thank you.
No.
And what's x? 10 root 3.
Yeah, this is really tough.
Okay. Next one. So, 12 in this case, the altitude, this is actually the longer leg. Right here, this would be the hypotenuse, and x is actually pointing to the entire side. Half of x would be to here. Okay, so what's the relationship between the longer leg and the shorter leg? The longer leg is square root of 3 times the shorter leg. So how do we figure out what that's going to be, shall we? Okay, so if I take 12 divided by square root of 3, that's going to give...
Oh, it's like the shorter.
Remember, the longer leg is equal to square root of 3 times the shorter. So if I divide by square root of 3 on both sides, I'll get the shorter leg.
Wait, don't you need to multiply it by 6 now?
Okay, this is 1% of the time. Is that hard? Wait, 12 root 3 over 2?
So we should not leave it as 12 over root 3.
Correct.
Cool. I was making sure.
Okay, just a minute, guys. Okay, so, well, x is going to be twice whatever the shorter leg is. We get the shorter leg by dividing by square root of 3. Right? Does it, I guess I'm not quite sure. Like here, this is 12 divided by root 3. So I'm going to multiply by root 3 over root 3. So I get 12 root 3 over 3, which is 4 root 3. And that's the shorter leg, which is half of x. So if this is 4 root 3 here, the whole thing would be 8 root 3. And since x and y are virtually just showing two sides of an equilateral triangle, x and y are actually the same length. Okay, do you understand how I got 4 root 3?
Yeah.
Why? Sorta?
What do you mean times shorter leg?
Oh, right here. Look at this here. The longer leg is equal to square root of 3 times the shorter leg. So if I know the longer leg is 12, I'm going to divide both sides by square root of 3. Divide by square root of 3, divide by square root of 3. So the shorter leg is going to be 12 over square root of 3, and then I rationalize. And when we rationalize, I get 4 square root of 3. Right here, this is 4 root 3. So all the way across is 8 root 3.
Yeah, I'm not understanding what
This
the
is
y
an
is.
equilateral triangle.
This is the hypotenuse.
I understand that y is on.
Well, okay, do it this way. Ignore all this and just double the 4 root 3. Remember the hypotenuse is always twice the shorter leg.
Miss Casey, why do you always say in the other class, oh, take a stab at it?
It's just a inside joke we had.
Inside jokes. You guys have so many inside jokes about Tommy. It's not denying it.
It's not jokes.
I feel like we need some inside jokes.
No, we talk about 1, 2, 3, go.
Let's work harder and then we'll have fun.
Let's work harder.
They don't work on the whole time. I think I have the answer to number that example.
Okay, so
I think she's still doing that.
Okay, that's insulting.
I have a quick question.
Yes, Henry.
Can you refresh my memory of what is altitude inside of you?
Okay.
The what of the flag?
What is, anybody? What is an altitude?
Form
Shiley.
Okay, well, you draw the line in the middle and then you do the right angle and then both sides would be, well, it would also be the median, so both sides.
I only need to know the information. Thank you.
The altitude goes from the vertex and it goes perpendicular to the opposite side. That's just a review. That's the definition of an altitude. So if you have the perimeter, let's read the problem. The perimeter of an equilateral triangle is 18. So what does that mean each side would be? 6, 6, and we want to know the altitude. Well, if this is a 30, 60, 90 triangle, right, when we cut the equilateral triangle in half at the altitude, this would end up being 3. So the altitude would be, what? 3 root 3. Now, just a quick note. Sure. Whenever it says write exact answer, that means with the square root. Okay? We don't want to write it. Now, there are some decimals, like something with a 0.5 would be fine. But when I say exact answer, it means that you don't want to plug it into your calculator and get that decimal.
I got all of them and it was easy,
Got it?
which I'm really proud about.
Okay. All right, you guys go ahead and figure out the other correspondence.
Oh, but it's yes and no.
10 over root 2. So then it's 10 root 2. This is, what did I do?
You're on the right track.
5. So 5 root 2 times 4. 20 root 2 is 8. I can do the next one.
No, wait, Ali. I still don't understand.
How do I scroll down?
No, we don't want you to do the next one.
How do you scroll down?
Ali, 45, 90.
Did you know that if you don't even touch the screen, it still draws? It gave it freckles. I gave it freckles. Oh, I'm gonna make it prettier. Can I do the next one? Oops, Miss Casey. Oh, I did it. 5 root 2 times 4. I don't know how to scroll back up.
Did everybody get 20 root 2 for example 4? Yeah. Okay.
I can do it. I can do
We
it.
explain why that is.
Multiply 5 root 2.
Okay, Ellie, scroll back.
I don't know how. I don't know how.
Be quiet.
How do you do this?
Oh, just use the mouse.
Oh. Whoa.
Okay, Jacqueline. You got that one?
No, don't.
Can you explain it to Jacqueline?
I got 10 root 3.
Okay, so the altitude is 5.
That's correct. No, what? I don't know. I don't know if I did the last one right, so I'm not gonna do it. I did it, but I don't know.
No, 5 root 6.
Allie, you forgot your pencil. Allie.
5 root
Allie, the right thing is always the fact.
is, yeah, over 3 is the 2 side, and then the bottom one is 10 root 3.
Okay, guys.
What? Oh, wait, now you got it.
Yeah, I'll explain, but I need you guys to be quiet.
Can I see if I did it right?
Let me explain example 5, and then you guys can have the rest of the class to work on homework. So, if the altitude of an equilateral triangle is 5 root 2, now the altitude would correspond to the longer leg. This is the longer leg in a 30, 60, 90. This would be the shorter leg, and this would be the hypotenuse. Now we don't have a formula you could come up with one relating the altitude to the hypotenuse, but it's easier to just find the shorter leg first. What do we know about the longer leg? Okay, so if we divide by root 3, we'll get the shorter leg. Let's just call that x for right now. So 5 root 2 over root 3. If we multiply by root 3 over root 3, we get 5 root 6 over 3. Remember, the longer leg is square root of 3 times the shorter leg. So if we're finding the shorter leg, we're going to divide by root 3.
So what that would be like good.
It's a 30, 60, 90.
So wait,
Hey guys, so take a look over here. I have a lovely poster that will not necessarily be up here all the time.
not for the test.
So, special right triangle. So 45, 45, 90 is x, x, x root 2. Always. 30, 60, 90 is x, 2x, and x root 3.
Can you just leave that up?
No.
But that'll like,
No.
but people.
I'll leave it up right now.
But you need to correct it.
Everybody's going to be looking over. I don't want.
Yeah,
So you
that's what
put
okay,
five.
using
What
this
did I
in
tell
real
you?
situation,
You need-
we'll
My
have
favorite
that.
teacher note said that. We put all the answers.
So the very first thing I told you is that you're going to be using this in algebra 2 and pre-calculus and calculus, and there you go. You need to learn it well. In your wallet. There you go.
In life, when I'm ever going to use it, if I always if I forget it, then I can just Google it.
Thank you.
So,
And we get
I realized it there.
Happy birthday. Brad.
What's at the
Brad.
airport?
I'm going to look at colors. Brad. Brad. Michael. Hi.
I had his brother when he was in ninth grade. And I had the other brother when he was in ninth grade. And I have his brother Josh as a senior now.
I didn't like him.
Not at all. No. Okay.
Wait, how is it?
How are they different? Colleges.
Actually, it's
Oh, yeah.
okay.
Wait, do you have the other brother?
There's also Brandy Brandy. But we won't.
I like that.
Okay.
We're doing Brandy.
Take the longer leg, divide by root 3, rationalize. You should get 5 root 6 over 3. That's this piece. Okay, to find the side, we're just going to double that. Because, remember, this is an equilateral triangle. The shorter leg is half of the side. So if we multiply this by 2, now remember, whenever you multiply fractions, you multiply it to, like picture this is 2 over 1, and you multiply the top numbers, multiply the bottom numbers. So you get 10 root 6 over 3. That's the length of each side. Now the other part of the question,
Is fine.
so this was one part. The side is equal to 10 root 6 over 3.
Wait, isn't it supposed to be over 9? It's supposed to be 96.
Okay, remember, I just told you. Here. Put 2 over 1. When you multiply fractions, you multiply straight across. So it's 2 times 5 root 6 and 1 times 3. Now for the area, it's base times height divided by 2. So what's your base? 10 root 6 over 3, and your height, 5 root 2, and we want to divide the whole thing by 2. It's a little bit of computation, but so when we multiply, you can put the 5 root 2 to triangle. Base times height divided by 2 is the area for, or 1/2 base times height, however you want to do it. Which 2? There's a lot of 2.
Bless you.
Yeah, you can do that. So here, what do we get? 50 root 12 over 3.
But isn't that 50 root 3 over 2? Because we have 2 that's under it. Wait, isn't there 50 root 12 over 3 over 2?
In 12. Can you get something by that?
Yeah. 50 root 12 over 3 over 2.
Yeah,
over
over
2.
Yeah, over 2 is the same as multiplying by 1/2. I just made it so. What's square root of 12 simplified to?
The 2.
You have 3, 2
It's
and 3, right?
Oh, yeah.
25. How do you get 25? Oh, from the...
Oh, I cross canceled here, guys. So if this is 50 and this is 2, I can cancel 2 into 50. Square root of 12 is 2 root 3, and then when we multiply 25 times 2, 50 root 3 over 3. The root 3 and the 3 can't cancel because one's in this radical and one's not. What's the square root of 12? Square root of 12 is 2 root 3. Yeah, you guys got to work on some of those square roots. If you want to come in a bonus and practice some of them, I'm happy to, have you come up to the board and you can just go through a whole bunch. You guys need to get quick about those.
What about what if you have like these huge numbers, like not saying huge, but like if you have like it close to the 5